Okay, you're welcome to Life Changer Tutorials. Here we're going to be looking at partial fraction case 4. We've seen case 1, 2, and 3, so this is the final case for partial fraction. Case 4 is an improper fraction in which after dividing can lead to case 1, case 2, case 3. Now the difference between case 4 and the other 3 cases is that case 1, 2, and 3 are all proper fraction. How do you know a proper fraction? The numerator is always less than the denominator. But an improper fraction, the numerator is usually greater than the denominator, such that you can divide. So when there's a possibility for division, it means it is an improper fraction. Okay, in a normal fraction, if I have 1 over 2, we can call this a proper fraction because 1 is less than 2. But if I have 3 over 2, this is an improper fraction because there's a possibility of dividing and having a remainder. 3 divided by 2 is 1, remainder 1, then all over 2. Okay, so in the same way, quadratic fractions also, polynomial fractions also can be improper. And that's for case 4. So how do you treat case 4? You first of all divide, because there's a possibility of division. Then you can now apply any of case 1, 2, or 3. Now let's look at the first example here. So we have solution. We have x squared plus 2x. Now I told you there's a possibility of dividing. So let's make that division now. In here we have x squared plus 2x plus 3. Then here we have x squared plus 2x plus 1. Now, whenever you're dividing polynomials, it's always the first term. Here, dividing the first term is always the first term to the first term. Don't forget. So here we can say x squared will divide x squared to give us 1. Of course, x will give us 1. So we have our 1 here. Then we'll multiply 1 by all the values here, all the numbers here. So 1 times x squared will give us x squared. Then 1 times 2x will give us 2x. Then 1 times 1 will give us 1. And of course, you know what we do here, we subtract. So x squared minus x squared is 0. 2x minus 2x is 0. That's minus, remember? Minus plus is minus. So 2x minus 2x is 0. Then minus plus is minus. Then 3 minus 1 is 2. Okay, here we can no longer divide because x squared cannot go in 2. So that's our remainder. Now this is our quotient, this is our divisor, this is remainder. So you are going to write it such that your polynomial will be equal to your quotient plus divisor all over remainder. Remainder over divisor. Okay, so that means the whole of this division now, my quotient is 1. So after dividing, I get 1 plus the remainder is 2 all over the divisor, which is x squared plus 2x plus 1. So the purpose of case 4 is to bring out our quotient. Now this we can resolve into partial fraction. You have your x into x squared plus 2x plus 1. With this, the denominator can be factorized, so it's the same thing as saying 2 over x plus 1 all squared. When we factorize the denominator, we are going to get x plus 1 squared. And this is exactly case 2. And how do we break this down into partial fraction? It's going to be a over x plus 1, then plus b over x plus 1 squared. At this point, you remember, we can find the LCM here of the right hand side. What is my LCM? Is x plus 1 squared. That's the LCM. X plus 1 can cancel one of these to give me x plus 1. X plus 1 times a will give me a into x plus 1. Now plus x plus 1 squared can cancel x plus 1 squared to give me 1. 1 times b will give me b. So if the denominators of the left hand side cancel out the denominators of the right hand side, we are going to get 2 equal to a into x plus 1 then plus b. At this point, you can pick out the factors the factor, one of the factor here is x plus 1. So we say let x plus 1 be equal to 0. That means x is minus 1, then substitute. If we substitute x to be minus 1 here, we're going to get 2 equal to a minus 1 plus 1, which will give us 0, then plus b. So if this is 0, it means my b is equal to 2. We don't have any other factor here to find a, so we can choose any number at all of our choice. So we can say let x be equal to 0, and if we choose that, it means that 2 will be equal to a into 0 plus 1, then plus b. Okay, so 2 equal to 0 plus 1 is 1. You have a plus b. We've got our b to be 2 already, so this will be 2 equal to a plus 0. So what is your a? A plus 2. So what is your a? Your a is actually equal to 0. So the value for a is 0. That means this cannot be broken down into partial fraction. It means that 2 over x plus 1 squared is equal to 0 over x plus 1 plus 2 over x plus 1 squared. Of course, you know what that means. It means this cannot be broken down into partial fraction. So at this point, we can leave our final answer now. That means x squared plus 2x plus 3 all over x squared plus 2x plus 1 can be written as 1, that's our quotient, remember, plus 2 all over x plus 1 squared. Good. Okay, we see the second question. If you observe something here, look at the denominator. The highest power here is x times x, which is x squared. But here the numerator, the highest power here is 2x squared. So there's possibility of dividing. So what we do is we expand the denominator to make our divisions first. We have 2x squared minus x plus 5 all over this multiplied by this is going to give us x squared minus 1 by opening the bracket. When we open the bracket, we're going to get x squared minus 1. So we perform our long division. In here we have 2x squared minus x plus 5. Then out here we have x squared minus 1. Now don't forget, is the first term here that will divide the first term here. So x squared will divide 2x squared 2 times. So we have 2. Now 2 we multiply 2 times x squared will give us 2x squared. 2 times minus 1 will give us minus 2. Let me place it under this, minus 2. So here we subtract. Now you may wonder, why did I place this under this? Because each term will add to like terms. So x cannot add 2. It has to be 5. 2 under 5. Okay, so we subtract. 2x squared minus 2x squared is 0. Minus x has nothing to add here, so we'll bring it down here, which is minus x. Then for this, we have minus minus, which is plus. So we have 5 plus 2, which is 7. Okay, so if we use our formula, it means that the whole of this breakdown is equal to our quotient, which is 2, plus our remainder, which is minus x plus 7, all over our divisor, which is x squared minus 1. So we can go ahead to break this down into partial fraction. Okay, so we have minus x plus 7 all over, return this back to the factor, which is x minus 1, x plus 1 is the same thing as a over x minus 1 plus b over x plus 1. Okay, now here we can find the LCM at this point. The LCM here is x minus 1, x plus 1. Okay, and x minus 1 can cancel this out to give us, to remain x plus 1 times a. we are going to get a into x plus 1, and plus this, the same x plus 1 cancels x plus 1 to give us this times b will give us b into x minus 1. I'm sure you can remember that. So at this point, the denominator here can cancel out the denominator here. So what we are going to be left with is minus x plus 7 is equal to a into x plus 1, then plus b into x minus 1. So we can pick both factors to find a and b. So let x plus 1 be equal to 0. So that means x is minus 1. So if we make that substitution, this is going to be minus 1 plus 7 equal to a into minus 1 plus 1, then plus b into minus 1 minus 1. Okay, already this is 0. So minus is plus, that's 1. 1 plus 7 is 8 equal to, here we are going to get minus 2b. So my b now is minus 4. So we have the value of b, which is minus 4. So we can go ahead to find a by using the other factor. Let x minus 1 be equal to 0. That means x is equal to 1. So if we substitute there, we are going to get minus 1 plus 7 equal to a into minus 1 plus, a equal to 1, 1 plus 1, then plus b into 1 minus 1. 1 minus 1 here is 0, makes the whole of this 0. So minus 1 plus 7 is 6, equal to 1 plus 1 is 2, so you have 2a. So at the end of the day, we get that a is equal to 3. Beautiful. So we can say that minus x plus 7 all over x minus 1, x plus 1 is equal to a, which is 3, over x minus 1. Then plus b is minus 4 over x plus 1. So coming back to our original question, that now implies that 2x squared minus x plus 5 all over x minus 1, x plus 1 is now equal to our quotient, which is 2, then plus the rest of this, 3 over x minus 1 minus 4 over x minus 1. Okay, the third example, the numerator is s cubed. This is also an improper fraction. There's possibility of division, so we divide. We use a long division method. S cubed plus 2x squared minus x plus 5 divided by x squared minus 10 x plus 21. So remember, the division is always first term against first term. So x squared divided by s cubed is going to give us x. So if we open the bracket, x times x squared will give us s cubed here, right here. X times minus 10x will give us minus 10x squared. Then x times 21 will give us 21x. So here, at this point, we can subtract. So s cubed minus s cubed 0, okay? Minus is plus, so 2x squared plus 10x squared will give us 12x squared. Then minus plus here is minus, so minus x minus 21x is minus 22x. There's nothing to add this here, so we'll bring it down, which is plus 5. So there is still possibility of division, so we still divide. So this is x squared dividing 12x squared, that will give us 12, so we have plus 12. So 12 times x squared will give us 12x squared. 12 times minus 10x will give us minus, that's a big number, 120x. 12 times 21, that is going to give us 210 plus 42. Okay, that means 252, so that's plus 252. So here we are going to subtract. Okay, so this minus this is 0. Minus plus here is minus, so minus 22 plus 120 is going to give us 98x. The minus plus here is minus, so 5 minus 2, 2 is going to give us minus 247. Okay, so we get 9x minus 247. So using our breakdown, our quotient here, the whole of this is equal to, our quotient is x plus 12, okay, plus our remainder is 98x minus 247 divided by our divisor x squared minus 10x plus 21. This is awesome. So we can go ahead to break this down into partial fraction, which is going to be 98x minus 247 all over. When we factorize this is factorizable, so factorizing this is going to give us x minus 3 and x minus 7 to factorize this. So we have this, which to break down into partial fraction is going to give us a all over x minus 3, then plus b all over x minus 7. Which after finding LCM, we are going to get 98x minus 247 is going to give us a into x minus 7, then plus b into x minus 3. Okay, if we take x minus 7 equal to 0, we are going to get x being equal to 7. Now substituting that value here, we'll get 98 times 7 minus 247 is equal to a into 7 minus 7 plus b into 7 minus 3. Okay, 98 times 7 will give us 630 plus 24. That's 630 plus 56. That means 686 minus 247 equal to, this is 0. 7 minus 3 is 4, so you have 4b. Okay, so this, subtracting this, we're going to get 9 here, we get 3 here, and we're going to get 4 here, equal to 4b. So here we get our b to be equal to 439 all over 4. Okay, now if we pick the other factor, which is x minus 3, we say let x minus 3 be equal to 0. That means x is equal to 3, and substitute it here. We're going to get 98 times 3 minus 247 is equal to a into 3 minus 7 plus b into 3 minus 3. Okay, this is 0 already, so that's out. So we have 98 times 3, 270 plus 24, so that's 294. 294 minus 247 is going to give us minus 4a. Okay, if we subtract this, this is going to give us 747 equal to minus 4a. So a now would be minus 47 all over 4. At this point, we can now conclude that x cubed plus 2x squared minus x plus 5 all over x squared minus 10x plus 21 is equal to the quotient, first of all, which is x plus 12, then plus a, which is minus 47 over 4 into x minus 3, then plus b, b is 439 all over 4 into x minus 7. Thank you very much.